All right, so we're still looking at calculus differentiation. Okay, we've got two examples here. What x squared times the natural log of x to the power 5, right? So we can see two different functions here. So we're going to apply the product rule, okay? So if you remember the product rule, okay, it's d dx, all right, f times g, all right? And we're going to get f prime times g plus f times g prime. Okay, so we're going to pick our f and our g. All right, so our f is x squared, f prime, okay, so f prime, we derive x squared, all right, we get 2x, all right, then we select our g prime. I will select our g first. It's the natural log of x to the power 5. All right. If you remember differentiating natural logs, all right, let me write it down here. D du, all right, the natural log of u equals to u prime, all right, the derivative of u over u, all right. So, okay, for our natural log here, which, all right, x to the power 5, we're going to say our u equals x to the power 5. Then u prime, when we derive x to the power 5, we're going to get 5x to the power 4. All right. So it's u prime over u. All right. So our g prime, okay, which is g prime, is going to be u prime is 5x to the power 4. And u is x to the power 5. All right. U is x to the power 5. Okay. So we can eliminate the x's, all right? The x's on the numerator, they'll all go, all right? And in our denominator, we're going to remain with x to the power 1. So we have 5 over x. So now we can put our solution together. Okay, we're going to say equals. So f prime is 2x. Okay, f prime equals 2x. G is the natural log of x to the power 5 plus f, which is x squared, okay, times g prime. G prime is 5 over x. 5 over x. So we can leave our answer like this, but these x's here, we can also simplify them, okay? this x will be cancelled, and this power 2 will be cancelled. So we're going to remain with 5x, okay? So we remain with x to the power 1. This x at the denominator can be cancelled. So we're going to remain with 5x. So let me just write it properly. Okay. Let me just erase the x on this other side. Yes. All right. So our answer is 2x, the natural log x to the power 5 plus 5x. Let me write it closer plus 5x here. All right. We can even factorize it further. Okay, we can factorize it further. Right, we have x here and we have x here. Right, so we can put x outside, and we'll remain with 2. So the natural log of x to the power 4. Okay, x to the power 4. Right, because this one will be affected. This x to the power 5 plus 5. We go to our second one. Right, we go to the second one. We've got 1 minus x cubed equals e to the power 2x. We pick our f and our g. F equals 1 minus x cubed. So f prime, right? F prime. The derivative of 1 is 0. The derivative of x cubed, all right, we're going to have negative 3 x to the power 2. Right, negative 3x to the power 2. We go on our next one here. We have g here, right? G equals e to the power 2x, okay? And then g prime is going to give us e to the power 2x multiplied by, right? We derive 2x, right? The derivative of 2x is 2. So g prime is t2 e to the power 2x. Right, so we're going to put our, let's put our answer. So we start with f prime. F prime is negative 3x squared. Negative 3x squared. Right, negative 3x squared. G is e to the power 2x. G is e to the power 2x. Plus, right, plus f is 1 minus x cubed. And g prime is 2 e to the power 2x. All right, and that is your answer. All right, if you want to factorize, e to the power 2x is a common factor. All right, e to the power 2x is a common factor, so you can also factorize. All right, so e to the power 2x, open brackets, my negative 3x squared plus 2, 1, open brackets 1 minus x. All right. So if you distribute the e times negative 3x squared, you get this. E to the power 2x times 2 open brackets 1 minus x cubed, you get this. All right. Similarly, above, oh, sorry, again. Above this one is x to the power 5. So it remains the same, x to the power 5. Okay, because when we distribute this x times 2 natural log of x to the power 5, we'll get this expression on top. So actually this x to the power 5 wasn't affected. And when we multiply x times 5, we're going to get 5x. Yes, so those are the answers for our questions.